What I'd like to talk about today is a little bit of the theme we've been talking about here at the meeting, bringing analytical technology closer to the patient, so making technology more accessible. And I want to talk about two technologies, bringing forward a simple technology, making it even more simple, and then a complex technology and bringing that forward as well. So let's jump right into the first technology. Now, that's a simple single quad mass spec analysis of an LC-UV peak, and it kind of shows you the insight into what you can get from orthogonal detection, even in a simple case there, where you have one simple peak of interest. You want to know that the peak didn't move when you're doing method development, or that it is in fact homogeneous. But some of the challenges that we've been seeing here in the meeting is, will this work within my lab? Is it fit for purpose? Is it cost effective? All right, so what we've done in this simple case, next slide please, is I want to introduce you to the Acuity QDA detector. And what we've done here is we've brought the mass spec detector to the LC technology. So we removed the hyphen. Instead of LC-MS, this truly is an LCMS system. This is what we heard from some of the folks we were working with on this technology. And the only game I had there was just revealed, which was spot the mass spec. So on the bottom of that, you can see that's where the mass detector is in the system. So very simple, easy to use, cost-effective solution to integrate right into the stack of your LC systems. So the next session I want to talk about is, what about for the analyst who needs to look at samples that are way more complex than just a simple peak and get that confidence? Well, next slide, please. This might be a situation where, you know, we talk about in vivo med-ID studies. There was the food analysis session last night. You might be looking at pesticides and complex matrices. Here's a situation where you need to fish out your entity in a very complex sample. Next slide, please. And what we can do is add an extra dimension of separation to, in addition to chromatography and mass spectrometry, and bring into the equation ion mobility separations. And not just get the separation, not just get filtration, but also get intrinsic properties of the molecules in addition to chromatography and mass. Next slide, please. So what I'm talking about here is, instead of just adding a separation, getting a drift time, getting the intrinsic property of the molecule, next click please, which would be the collisional cross-section, which we can use to characterize our components a little more completely in challenging situations. Next slide. So if we look at the complex analysis here, this might be, or it actually is, a sample of propranolol in matrix over the course of the peak of the analyte. And looking at that in its totality, you can't really see it. Now, using chromatography, we can just get its the entity's elution profile and simplify the spectra by using chromatography. Next click. And just time-align components that elute at that moment in time accurately. And we've been doing this technology for a number of years. Now, if we know the intrinsic property of a target analyte we're looking at, we can filter out by collisional cross-section and zoom in right into our final analyte and get confidence, next click please, to our single entity. All right? Now, that's what ion mobility can do for us in addition to the mass resolution and the chromatographic resolution. But what full ion mobility spectrometry can do for us is illustrated in the next slide. And what we have here is, instead of a filtration process, we have a spectrometric where we get the process where we get the full spectrum. So here we can see at an identical accurate mass, we can see there could be multiple components in this run. So we can extend the capability of the ion mobility, not just for separation. I don't want to go into all the possible applications. That's why we're downstairs. You can come see us and ask about it. But we can take advantage of collisional cross-sections and intrinsic properties of the molecules to get more information about our samples, not just separation. The key point in what's new this year is we've integrated the collisional cross-section into the process. And what I mean by that is, with the Synapse G2SI and Unify CCS Research Edition software, these four components are accessed routinely: retention time, accurate mass, collisional cross-section, and intensity. We're downstairs at booth 19. If you have any questions or are intrigued by this, please come seek us out and we'll be happy to talk to you.
Thank you, Iggy. Nice job.